Hello students, good evening. Okay, yes. So I hope you guys have solved today's question. So the topic for the day is linked list, right? So basically, from today, for the next 5 to 6 sessions, we'll be focusing on data structures, right? So starting with linked list. So today, what we'll do is we'll just brush up what is data structures, and then we'll start with today's question. All right. Yes, so starting with data structure, basically we call this as a storage unit, right? For what do we use this data structure? We use this to store and organize data, right? And why do we need to organize data? Because once the data is stored and organized in a proper manner, it will be easy to uh, you know uh, like we can update, or if we have to access the data, it will be easy. Yes, so that is the reason we go for data structure, right? It is just a way of arranging data on a computer so that it can be accessed and updated efficiently. So basically, for efficient access and updation, we go for this data structures. Okay. Yes, coming to classification of data structure, we have two types of data structure. One we call as linear data structure, and the second we call as non-linear data structure. Okay. And again, in linear data structure, we do have two types. So the first is static and the second is dynamic. Okay. Arrays is a data structure, right? This comes under static data structure. And the reason is, once we declare the size for an array, right, we cannot, change or modify its size. So since this is the reason, we categorize array as static data structure. Okay. And coming to dynamic data structure, we have a linked list, stack, and queue. When I say dynamic data structure, it is like, we can change or modify the size when necessary, right? There will not be any fixed restrictions on size. So that is the reason we categorize linked list, stack, and queue under dynamic data structure. Okay. And again, we have a nonlinear data structure where tree and graphs comes under this nonlinear data structure. Okay, so basically all these are the classification of data structures. Yes, and coming to this is just a comparison between linked list and array. So the basic difference between linked list and array is that in array we'll have array indices, right? So where it will start from 0 and it will go till length minus 1. Okay, if we have to access any array element, what do we have to do? We have to just give the index and then we will be able to access it, right? But this is what we do in array. But when we go for linked list, we don't have any indexes, right? Basically, we have a data part and next part together called as a node, right? Basically, linked list is collection of nodes. So let us see what is a linked list. Yes, a linked list is a linear data structure where the elements are not stored at contiguous memory locations. Okay, so the main difference between array and linked list is that about the memory. In array, we store the elements in contiguous memory locations. Okay, where let us say the index starts from 0 and the address is 100. So the next element will be stored in the address 102 or 104 depending on the compiler. Okay, so that is why we say array elements are stored in contiguous memory locations. Yes, but when we come for linked list, we don't have the memory, like the elements will not be stored at contiguous memory locations, right? So that is the difference between an array and linked list. So coming to types of linked list, we have singly linked list, doubly and circular linked list, right? So all these are the types. So today we'll be focusing more on singly linked list. Yes, so when we say singly linked list, it is just a collection of nodes. Okay, when I say node, I have two parts in my node. The first is data part and the second is next part. So basically this data and next together we call as a node. Okay, so this data, what it will hold? Just the data part. Okay, it can be an integer, it can be a float value, or it can be a character or string, right? So this data will be holding the value. This next part, what will that hold? The address of the next node in the linked list. Okay, so this next will be holding the address of the next node. So if we have to traverse through the linked list, we have to go through an important term called as head. Yes, so this head will be storing the address of the first node. So this is very important in linked list, right? So without accessing the head, we will not be able to traverse through the linked list. So this head will be holding the address of the first node. Okay, so that is what we call as head. And then we have a term called null, right? So remember, in a singly linked list, always the last node's next part will be pointing to null. Okay, so if you keep on traversing the linked list and at certain stage, if the next part is null, what does that mean? It means that we don't have any more nodes followed by that node, and that marks the end of linked list. Yes, so always in a singly linked list, the last node's next part will be pointing to null. Keep this in mind. Okay. Yes, so every node contains some data and pointer to the next node of the same data type. Okay, if I say the first node is of int data type, the second node should be also of integer. Okay, it should not be any float or string. Okay, so it allows the traversal of data only in one way. Okay, so the traversal will be possible only in one direction. Yes, so this is what we call as a singly linked list. So now coming to our problem for the day. So I hope you guys have solved it. Yes, so let us just read the problem statement. Dave is tasked with creating a program that efficiently finds the middle element of a linked list. Okay, so basically we'll be given a linked list and we should find the middle element. Yes, well, there are two conditions here. If it's an odd length linked list, we should return the middle element. If it's an even length linked list, return the second middle element of the two elements. So basically we'll be given a linked list, right? A singly linked list. What we should return? We should return the middle element. So this is basically the question. Yes, so I have a sample linked list here. I hope this is visible. Yes, so I have a singly linked list. So where the green colored parts are called the next part, right? Where this will be holding the address of the next node. So I have like seven nodes with me. So the goal is to find the middle node. So here, what is the middle node? So this 4 is the middle node. Okay. So if our linked list is 1, 2, 3, 4, 5, 6, and 7, we should return 4 because that is the middle node of this particular linked list. Okay. So to solve this, we have an interesting, concept of pointers, right? So we'll solve or we'll find the middle element using two pointers. Okay. So the first pointer we'll call as, so here before starting, we'll have a pointer head, and what that will store, it will store the address of the first node. So here the address of the first node is 100x. So head will be storing the value of 100x. Okay. So to solve this particular problem where we have to find the middle element, we'll make use of two pointers. Okay. So the first pointer we'll call as slow. Okay. And the second pointer we'll call as fast. So by moving these two pointers, we'll try to find our middle node. Okay. So one important thing about these two pointers is that, so this slow pointer will move one pointer at a time or one node at a time. Okay. If we are traversing this slow will be moving one node at a time, which means if I say slow is equal to slow of next, so this will go or move to the next node. Okay, which means this will move only one node at a time. But this fast pointer, this particular pointer will move two pointers at a time. I mean two nodes at a time. Okay, so we'll find the middle element using two pointers. So we call that as slow and fast. This slow pointer, if we traverse this will move only one node at a time. Okay, but this fast pointer, this will move two nodes at a time. And how this will be monitored? By giving this syntax: fast is equal to fast of next. Okay, so initially let us begin both our fast and slow with head pointer. Okay, so now fast is also here, slow is also pointing this. Okay, so let us just try moving our pointers. Okay, so this slow will move one node at a time. Okay, so first time it will move slow of next. So first time my slow pointer will be here, but fast will be moving two pointers. Okay, so fast dot next is 101 dot next, so it will go here. So this fast will be moving here. So this is for one traverse, one move. Slow will move one node at a time, and fast pointer will move two nodes at a time. So again, if we move our pointers, this slow will move one node, okay, but this fast will go two nodes. So this fast will be pointing here. Okay. So again we'll just move. So the base condition to end this loop is we have to check if fast is equal to null. Okay. So check if fast is equal to null. This is not equal to null. So keep moving your pointers. Okay. So the end condition is fast is equal to null. So our fast pointer is pointing here. We're checking if it is equal to null. No. So we'll just move our slow pointer. Okay. Move our slow pointer. This will move two nodes. So fast will be here. So now check this next part. So this is pointing to null, right? Which means that we reach the end of this linked list. Okay. Once your fast or the next part of this fast pointer is pointing to null, if you return your the data part of your slow node, this will be pointing to the middle element of the linked list. Okay. So once your fast pointer reaches the end of linked list or that is null, your slow pointer will point to the middle node of the linked list. Okay, I hope this is clear. So basically we have two pointers, slow and fast. Both pointers will be used to find the middle element of the list. This slow pointer will move one node at a time, but fast pointer will move two nodes at a time. Okay, so initially we'll start both our fast and slow pointers with head. Okay, so here the head is the first element 100x. Yes, so we'll move our slow one pointer or one node. At the same time, fast will move two nodes. Yes, so you'll keep on checking the condition if fast or the next part of fast is equal to null. Okay, if it is not equal to null, move your slow pointer once and fast pointer twice. Okay, so if you keep on traversing at one point, you'll reach or the next part of fast will become null. At this stage, if you return your slow pointer, you'll get the middle element of the linked list. Yeah, so this is how you will solve this particular problem. So let us just try writing out the code for this. Yes, so I already have my main function here. Yes, so the first line of input is the number of elements in the linked list. Okay, so for that I have a variable n. Yes, so using a for loop, I'll add that to the linked list. Okay, so if you read the question properly, there is a condition to insert this. Right, populate the linked list by inserting each element to the front of the linked list. It means we have to insert the elements to the front of the linked list. So to insert elements, we have a function called push. Okay, so where we'll pass the head value and the elements to be inserted. Okay, yes, so we'll just write our function to insert a node at the front or beginning of the list. So node star, we'll have to name our new node, right? So we'll name this new node. Okay, equal to new node. So basically, we'll have to write our structure definition, right? So basically, every node has two parts, right? So one is data part, and the next is next part. Okay. So in this particular question, the data we have is of type int. Okay. Yes. So what is this data? This next part hold basically the address of the node. That is also a node, right? So this is self-referencing to this particular node. So node star next. Yes, so this is how you define a structure for a singly linked list. So we'll have a node, a name new node, right? We'll be creating a new node. Okay. So we have two parts of a node, right? So one is data, that is the data which we get as parameter here. Okay. And the next part, okay. Since this is insert, we are inserting at beginning, right? We'll pass this as head. Okay, we'll pass the next part as head, and again we have to make this head as our new node. Okay, so this is how you will insert a node at the beginning of the list, right? You will create a node. Okay, the data part is what you get as a parameter, and the next part you have to make assign it to head and make the head new node as the head node. Yes, okay. So coming to okay, so now actually we have our number of elements in the linked list, and we got the elements and we pushed it into the singly linked list. Basically, we inserted all the elements at the front of the linked list. Okay, so now we have our main method print middle, okay, where we'll pass the head. Yes, so now we'll just have, if our head is equal to null, okay, we can just return. Okay, we'll just return nothing. If our head is null, it means the linked list is empty and we don't need to do any operations on that. Yes, okay. So now coming to our question, we have two pointers, right? So we have a pointer called slow, yes, and we have another pointer called fast. Yes, so initially both will be assigned to head, right? So we'll have two pointers, slow and fast. Both will be pointing to head first. Yes, so what is the condition? So we'll have to move our slow pointer by one step or one node, and we have to move our fast pointer by two steps, right? And till when we have to repeat this? Until our fast pointer reaches the end. So to check that condition, we'll be needing a loop, right? So we'll go for while loop. Yes. So while fast is not equal to null, okay, and fast of next is not equal to null. Okay, so we'll check these conditions. If our fast and fast dot next is not equal to null, it means there is some nodes present there. Okay, and we'll just move our slow and fast pointers. So as I said earlier, this slow pointer will be moving one step at a time. So slow is equal to slow of next and fast is equal to fast dot next of next. Okay, so this slow will move one node at a time and this fast will move two steps at a time. Okay, so this will continue until this fast or fast of next reaches null. So once this null is reached, so if we just return the slow pointer, yes, so we'll get the middle node. Yes, so we'll just so this is the function for finding the middle element. Yes, so now coming to the printing, we'll have a pointer or temporary variable called current that will be pointing to head. Okay, so while current is not null, we'll just print the data. Okay, so let us have our code tested. So let us just run it. So we have our main method null equal to head. So slow of data. Yes, so what did we do? So we have our structure definition here, right? So we'll have int data, okay, and we have a next pointer pointing to the next node, right? And we have a function to insert a node at the beginning of the linked list. Yes, okay, so in that what did we do? We have a new node, right? So where we'll have a name for this. So the name of the new node will be new node, okay, equal to new node. So we'll have our data part, which is what we get as a parameter. Yes, and the next part will be, we are assigning the head to the next part, okay, and the new node will make us head node. Yes, so this is what we do to insert a node at the beginning of the list, right? Again, so coming to finding the middle element of the list. So we'll just check for a condition. If the head is equal to null, we'll just return, right? We'll return nothing. Okay. Again, we have two pointers, slow and fast, right? So this slow will be initially both slow and fast will be pointing to head. Yes. So again we have to move our slow pointer and fast pointer until this fast pointer reaches null. Okay, so we'll have a loop where we'll have our fast pointer and fast of next is not equal to null. Right, once we see this is not equal to null, we'll move our slow pointer by one step. Okay, and the fast pointer by two steps. Yes, so this two steps will be continuing until the fast or fast of next reaches null. Okay, so once this is equal to null, if you just print the data part of this row, yes, we'll get the middle element. Yes, so we'll have our main method, we'll have n I plus plus, right, we'll get the value, we'll push it. So while current is not equal to null, see out current of data. So we'll have our gap here. Okay, yes, so this is what. Okay, so let us have a cout statement, middle element. Okay, so now we have our middle element pointing to 3. Yes, so this is the result once we insert all the elements at the front of the linked list. Yes, and this is the middle element. Okay, so yes, I hope so. This is basically the idea of printing the middle element of the linked list. Okay, so just have two pointers, fast and slow. This slow pointer will move one step at a time. Fast pointer will move two steps at a time. Okay, so just keep moving your pointers until the fast or fast of next reaches null. So once this is equal to null, if you just print the data part of your slow node, you will get the middle element. Yes, so I hope this question, the explanation and the question is clear to you. If you have any doubts, you can just post it in the comments. Okay, so we'll just clear it out. If you have any doubts, you can just use the comment box and post your queries. So if you have no queries, we can just wind up the session and we'll meet you in the next session. Okay. Yes. Thank you, students. Good night.